So despite the caveat that we don't want to rely on environmental determinism to infer civilizations, their responses, their social structure, etc., we will continue to rely on papers that kind of implicitly use that philosophy. So let's start over the Middle East with two time slices. One is the mid-Holocene, so mid to late Holocene records of climatology in Mesopotamia region. In the next slide we look at a graph which shows various marine records, various cave records, various stalactites, stalagmites from the caves, and so on, and they are used to infer the precise timing of the aridity and dust loading over the Middle East. So you can see here the time series kilo years before 1950. So just calibrate yourself to see how much behind that is. So that gives us almost 1950 years plus minus the age shown here in terms of if you want to go back to Common Era. We're always switching between Common Era and years going back from the baseline in the 20th century, like 1950, so it can be confusing unless you are quick at translating those. So we are looking at delta O18 from various cave records, delta C13 from the stalagmites and stalactites, magnesium calcium temperature records, and so on. And they also attached are the regional climate proxies from the different sites here, marking off the various periods of interest. And you can see the dry periods marked here. So there is small dispersed settlements coming out of coming into the middle Holocene. So beginning of the state level societies happens during this period of 4.5 to 4.4 kilo years before 1950, and this dryness, which begins here around 4.25 or so, lasts for a while. Okay, so these are kilo years, so at least multiple centuries. 4.1 to 4.2 is a century. So you can see that the Akkadian Empire ended in the middle of this dry period, and then when the dry period ended, there was resettling of the Kabul plains. Okay, so this is just a study that looked at precise climate events and combine them with archaeological settlements to infer the impact of dryness, big one being of course the end of the Akkadian Empire. This new paper looks more in detail at a more recent period, just about in the 5th and 6th century Common Era, and droughts and societal changes are looked at here in the context of environmental change and the emergence of Islam in late antique Arabia. In Arabia, the first half of the 6th century Common Era was marked by the demise of Himyar, the dominant power in Arabia until 525 CE. Important social and political changes followed, which promoted disintegration of the major Arabian polities. Okay, so here we present hydroclimate records from around southern Arabia, including a new high-resolution stalagmite record from northern Oman. These records clearly indicate unprecedented droughts during the 6th century Common Era, with the most severe aridity persisting between 500 to 530 Common Era. So that's a serious length of dry period, even in a desert where there is a few hundred millimeters of rain. If that gets reduced by a significant amount, then obviously there are going to be changes in societal structures and settlements, as we will see in a minute. We suggest that such droughts undermined the resilience of Himyar and thereby contributed to the social changes from which Islam emerged. So that's kind of an extrapolation there that not all anthropologists agree in terms of environmental determinism, but just in this context of this paper, we'll just look at it. Okay, so we are looking here at location and settlement maps. This is the map showing the location of key proxy records and the suggested extent of the Himyar. So this is the red region here, and Kinda with the green lines here. So this is the southern Arabian region. This is at the beginning of the 6th century CE. Black dashed lines denote the main trading routes, so you can see these dots being connected here into the inland, across the Red Sea here, and into the Arabian Sea region. It's well known that Arabs had figured out the changing monsoon winds to sail across the Arabian Sea to India and back based on the season. Okay, B and C show the settlement patterns in Himyar in the 4th century CE and 6th century CE. You can see the major cities, regular cities or smaller cities, and townlets and villages and unknown settlements. And the change is fairly obvious. In the 4th century CE, there are many more towns and villages here, reduced in number here. These still are there, but here also you can see the number of townlets have decreased in the 6th century. Number of cities, one remains, the other one has disappeared. New one appears here, and this one is still there. Zafar is still there. So do these settlements correspond to climate changes? Well, that's the interpretation, and also the further interpretation is that that led to reduced societal resilience and allowed for new religion to emerge, which is Islam, one of the youngest religions. We have invoked this kind of religious evolutions in the pharaonic times as well, based on climate impacts. Okay, so this is looking at rainfall in millimeters per year and Hoti cave and meteorological records. A and B show comparison of H12 delta O18 values, that's a site, and a this is the mean annual rainfall for Oman, and B is precipitation anomalies with respect to the 1978 to 1987 averaged of minus 1.8 per mil per parts per thousand, that is average for the Arabian Peninsula. So delta O18 values and corresponding precipitation amounts are being looked at for Oman and the Arabian Peninsula to infer the correspondence between stalactites, stalagmites, and other evidences and precipitation anomalies. Okay, more details coming back to the societal resilience and societies themselves. This is looking at the VPDB is basically the international standard for computing deficits, delta O18s, for example, and you are also looking at aridity in terms of diameters of particles that correspond to how dry the conditions are. So H12 delta O18 black and delta C13 in green, and stalagmite diameter red line records. Sorry, that's the stalagmite diameter, which corresponds to the amount of water dripping, the rate of formation, which also corresponds to groundwater seeping through and the precipitations. So here aridity increases and aridity decreases in that direction. Okay, the red shaded area shows EM anomalies with respect to 1978 to 1997 mean, so that's minus 1.8 parts per mil. Black triangles denote the thorium dates. Black shaded bars denote the estimated lifetime of kingdoms in southern and central Arabia. So the different ages are listed here, but this is what we are looking at, coming back from the 6th century Common Era here, but starting here at 6th century BCE. So pre-Islamic and Islamic is the split around the 6th century here. The Himyar here, and did they disappear? Ma'in and Kinda existed here. Kataban, Saba, and Hadramaut existed here. So you can see that this climate signal here and aridity associated with that is inferred as a cause, a driver for the evolution or emergence of Islam out of the reduced societal resilience. Looking at the climate proxy records and historic events in a bit more detail, key historic and cultural events in southern Arabia. Black bars denote ruling powers in southern Arabia here. Socio-cultural events with star symbols here, such as the disappearance of Himyarite inscriptions and destruction of the Dam of Marib. The H12 Delta O18 record from Hoti Cave, the red shaded area marks periods of below normal precipitation. So here, dryness with respect to the 1978 to 1997 average of the deficit of minus 1.8 parts per mil, Delta O18. Lake Nior titanium record, Dead Sea level, Jada Cave record, historic accounts derived from the Middle East after the black shaded curve, after reference 22 and 23, and Nar Lake record from Turkey, Sahia Lake record from India. So all together combined here, looking for droughts per decade, so getting away from the temperature and precipitation proxies to inferring droughts, lake levels, which also correspond to the amount of rain and runoff, and of course titanium, etc., also corresponding to river runoff, and these are the rainfall deficits here. So red regions are deficits, and the argument is that if you come from the 5th century CE towards the 6th century CE, these droughts made the Himayar unstable and disappear. Kinda and Aksum had also gone. Sasanian was here. The Great War, Justinian plague, and emergence of Islam are noted here. This is the last Himalayan text, the Himyaritic text, and the breaking of the Marib Dam, and so on. So, as I said, these kind of studies keep on coming out that still presume that environmental determinism still works, but I'm sure there will be responses to this paper talking about how we cannot always infer such things, especially emergence of a religion like Islam being directly related to aridity, social resilience, and disappearance of Himyar, and so on. Just keep in mind that as a caveat, and there are other texts which have talked about Islam, and obviously religion tends to have lots of texts associated with them. So let's come back and look at other details of the Middle Eastern region in the next podcast, keeping in mind that we didn't directly talk about agriculture in this context, but in general aridity and social resilience are directly related to food production, which relates, or trading. So you may be trading other goods for food or grains or spices and so on. Okay, so they are all related, even though we are not explicitly saying agriculture. Okay.